All right, math 8, let's do some math. We got lesson 6-3. We're going to do some division with exponents. So we've already done multiplication with exponents. We found out that when we multiplied and we had like bases, so the bases were exactly the same, that we would end up adding the exponents. So now we've got division. So when we have division, it works by reducing common factors. So for instance, 24 is 2 times 2 times 2 times 3. That's what it breaks down to, right? So like if I had 24, 24 is, I don't know, 4 times 6. And 4 is 2 times 2. And 6 is 2 times 3. So I can see here, by making this little factor tree, that the smallest parts of the number 24, as far as factors, multiples, are 1, 2, 3 2s, and 1, 3. So that's breaking down 24. And then 6 is 2 times 3. So we don't really think of it like this, but when we're doing division, what we're actually doing is reducing common factors. And here's what I mean. You see how I have a 2 in the numerator and a 2 in the denominator? 2 divided by 2 is 1. So I can reduce those because they become 1. And see how I have a 3 in the numerator and a 3 in the denominator? I can also reduce those because 3 divided by 3 is 1. And what am I left with after all these became 1s? I'm left with 2 times 2, which is 4. So that's why 24 divided by 6 is 4, because I'm just reducing these common factors. So that gets us to simplifying by expansion. So here I've got 3 to the 5th divided by 3 to the 2nd. Should I zoom this in? Is that too small? I'm going to zoom a little bit. Yeah, that's better. So that means we saw in our first unit, or first lesson in this unit, means that I've got 1, 2, 3, 4, 5 3s on top in the numerator. And I've got 2 3s in the denominator. So if I go back to what I was doing over here and reducing and making 1s, so I can reduce this 3 and this 3, that makes 1. I can reduce this 3 and this 3, that makes 1. So how many 3s am I left with? I'm left with 3 of them in the numerator. So my answer is 3 to the 3rd power. It works with variables as well. I've got 1, 2, 3 m's in the numerator being multiplied. And I've got 1, 2, 3, 4 m's in the denominator being multiplied. So I can start making 1s. M divided by m is 1. M divided by m is 1. M divided by m is 1. What am I left with? I'm left with m, but m is in the denominator. So my answer would leave an m in the denominator, but what do I put in the numerator? Let's go back to what we were reducing here. We were making 1s. M divided by m is 1. So we still have 1 in our numerator. That would be 1 over m. Next one, we got x to the 6th, y to the 3rd, and y to the 1st, and y to the 4th. So that means, oh man, I've got 1, 2, 3, 4, 5, 6. I should have made a problem with less letters. Then we got 3 x's in the denominator, and we got 4 y's. All right, so we start reducing the like factors. I've got an x on top, x on bottom, that makes 1. Another x and another x, that makes 1. Another x, another x, that makes 1. So I have reduced 3 x's, and then I've got a y in the numerator and a y in the denominator. So I will reduce those. What am I left with? I'm left with 3 x's in the numerator, x to the 3rd, and 3 y's in the denominator, y to the 3rd. So there's my final answer. X to the 3rd over y to the 3rd. All right, so look really closely at what we started with and what we ended with. and see if you can make up a rule for dividing with exponents. You can pause here, try to come up with your own rule, and see if you're right. So here I did 3 to the 5th over 3 to the 2nd, got 3 to the 3rd, m to the 3rd over m to the 4th, 1 over m, x to the 6th, y, x to the 3rd, y to the 4th, x to the 3rd over y to the 3rd. What does it look like I'm doing? If you said we're subtracting the exponents, you would be correct. So exponents of like bases are subtracted. So as long as the bases are the same, we can subtract their exponents when we're dividing. Simplify the 3 original problems using the exponent rule. Okay, so for this one, I would have started with 3, and then I did 5 minus 2. 3 to the 5 minus 2 is 3 to the 3rd, which is exactly what I got right there. This one would be m to the 3 minus 4, which is m to the negative 1. And we kind of see here that I had an extra m in the denominator. So an m to the negative 1 would indicate that my variable is actually in the denominator and not the numerator. This one, we've got x to the 6 minus 3, because we're only doing like bases, and then y to the 1 minus 4. So this ends up being x to the 3rd, y to the negative 3. And again, this y to the negative 3, I saw when I expanded it, it's indicating that my exponent and my base should be in the denominator. So my final answer is x to the 3rd over y to the 3rd. So what does a negative exponent indicate? It indicates that the base and the exponent should be in the denominator. All right, simplifying when we have coefficients and exponents. Remember, the coefficients were the numbers up front. The coefficients indicate how many times we're adding a number, whereas exponents are indicating how many times we're multiplying a number. Exponents and coefficients behave differently under division. Exponents, we found out that they're being subtracted. But the coefficients should just be reduced like you would do if we just had a normal fraction. Okay, so in this first one, I'm going to start by just looking at my 2 coefficients here. I've got 12 over 3. If you were just given this fraction of 12 over 3, you would probably go, oh, okay, 3 goes into 3 once, and 3 goes into 12 4 times. So that one reduces to 4. For the base, I've got x, and I've got an exponent of 6 and 4, and we subtract those. So 6 minus 4 is 2. So final answer, 4x to the 2nd. Notice that I had more x's on top than I did on bottom. That's going to indicate that my x's belong in the numerator. If I would have had more x's on the bottom, that would indicate that my final answer should have my base and my exponents in the denominator. Okay, next one. 10 and 24. What's the biggest number that goes into 10 and 24? If you guess 2, you're right. 2 goes into 10 5 times. 2 goes into 24 12 times. So, the coefficients reduce to 12 over 5. The base is y. We do y to the 7 minus 9. Now notice there were more y's in the denominator. So my y's should end up in the denominator. 7 minus 9 is -2. And remember, a negative exponent indicates that the base and the exponent should be in the denominator. So final answer would be 12 over 5y to the second. Next one. For this one, I've got -4 over 16. So those are my coefficients. I'm going to reduce them first. 4 goes into 4 once. 4 goes into 16 4 times. So 4 over 16 reduces to 1 over 4. And it's negative because of this negative sign here. And then I've got m to the 10 minus 3. 10 minus 3 is 7. So positive exponent belongs in the numerator. I could tell over here that my m's would be in the numerator because there's 10 m's in the numerator and only 3 in the denominator. So final answer would be negative m to the 7th. If you write -1 m to the 7th, you're not wrong. Just when we have a coefficient of 1, we don't normally write it. So our final answer, negative m to the 7th over 4. All right, last one of these. So what number goes into 42 and 35? Biggest number that goes into those two? 7. 7 goes into 42 6 times. 7 goes into 35 5 times. So 42 over -35 reduces to -6/5. And now I do my exponents. I have only a's on the bottom. So I'm going to leave those a to the 7th in the denominator. There's no a's on the top to reduce them with. For my b's, I've got b to the 8th minus 12. So I've got -6/5, and we said that 8 to the 7th has to stay on the bottom because we couldn't reduce it with anything above. And then 8 minus 12 is b to the -4th. All right, negative exponent. That means this belongs in the denominator. Final answer would be -6 over 5, a to the 7th, b to the 4th. Remember, you can always expand these if you can't remember what the rule is. Expand it like we did up here, and then just start reducing them down to ones. All right, we got 9 questions here. Go ahead and pause the video at this time if you're kind of doing this at home or whatever. See how you do with them. And then unpause after you've tried them out. And then you can see my answers. All right, hopefully you've paused. I'm going to do the problems. Here we go. Base of 32. We do 32 to the 8 minus 4, which becomes 32 to the 4th power. Next one. This is 9 to the 1st. So I do 9 to the 1 minus 3. That's 9 to the -2nd. And that indicates that I get 1 over 9 to the 2nd, or 1 over 81. Next one. I've got 15 to the 10th and 15 by itself. That means 15 to the 1st. So this would be 15 to the 10 minus 1, which is 15 to the 9th power. Next, I've got v to the 24th and v to the 23rd on the bottom. So 24 minus 23 is v to the 1st. So you can write your answer as v to the 1st or just v. Next, x to the 14 minus 20. 14 minus 20 is -6. So I have a negative exponent. So that means that belongs in the denominator, x to the 6. And I can tell that my answer was going to be in the denominator because I had more x's in the denominator than I did in the numerator. Next one. Over here, I've got a in the numerator and a on the denominator. Those reduce each other to make 1. They go away. And then we've got b to the 5 minus 6, which means I get b to the -1. Final answer, 1 over b. Negative exponents indicate that we should be in the denominator. Next, we got coefficients here. 18 and 3. 3 goes into 3 once. It goes into 18 6 times. So reducing that, I get negative 6 over 1. And then e to the 15 minus 9. That would be negative 6 and then e to the positive 6. So that belongs in the numerator. Nothing's in the denominator other than 1. You can put this over 1 if you want to, but you don't need to. Next, 9 goes into both of these, goes into 9 once. It goes into 63 7 times. So this reduced to negative 1/7. And then we do x to the 7 minus 6. So this is negative 1/7. And then x to the first power. It's a positive exponent, so it belongs in the numerator. Final answer, negative x over 7, or negative 1x over 7. Last one. What's the biggest number that goes into 48 and 20? It's 4. 4 goes into 48 12 times. It goes into 25 times. A negative divided by a negative is a positive. So that ends up being positive 12 over 5. Now my like bases, I've got d to the 5th and d to the 7. So that's d to the 5 minus 7. I've got f to the 1st and f to the 1st. Those reduce each other and make 1. They go away. So I've got 12/5 and I've got d to the negative 2. Negative exponent is indicating that it belongs in the denominator. So my final answer is 12 over 5d to the 2nd. All right, that's it. That's all I got for you. Math hard. See you guys later. Bye-bye.